Hello, my name is Hanfen Chen from McGill University in Canada. I'm going to present our work in horsepower, accelerating database queries for advanced data analytics. This is joint work with Joseph De Silva, Laurie Henry, and Bettina Kimi. We have developed a column-based in-memory SQL execution engine. It is novel for the intermediate representation called HOSIR. We translate the execution plans generated from the SQL queries to HOSIR. Then on the HOSIR level, we perform the compiler optimizations to generate efficient C code. Overall, HOSIR is a high-level array-based intermediate representation designed for SQL queries. It treats the table columns as regular vectors. Today, we are going to introduce a new framework called horsepower, which is built on HOSIR for data analytics with database queries. MATLAB is a popular array programming language widely used for data analytics. Horsepower supports MATLAB functions that it first translates MATLAB functions to HOSIR before generating the C code. We'll explain later how it actually works. Now, horsepower supports both the database queries and the MATLAB programs. We added additional support to allow MATLAB embedded as the use-defined functions in SQL statements. That is adding the data analytics into the database queries through the use-defined functions using a compiler-based approach. Then we explore how to optimize the HOSIR programs generated from both SQL queries and database queries and MATLAB programs in a holistic way. In the following, we are going to introduce the MATLAB to HOSIR first. So analytic functions can be written and tested in MATLAB easily because MATLAB is an interpreter-based language whose execution relies on an interpreter. So there's a compiler framework called MATLAB, which can compile MATLAB programs with the given type and shape information. We supply a new code generator that translates its intermediate code to HOSIR. We use MATLAB functions as the use-defined functions to integrate MATLAB into the database queries. Here is a typical simple examples for a MATLAB function. The function name is called revenue change scalar. So it takes two parameters, price and discount, and after multiplication, it returns the result. Then with a simple query, we have selected the sum, like total values of the revenue change for the price and discount with a condition discount. We can see that the query and MATLAB can be combined as a means of supporting data analytics in database queries. However, we need to overcome common challenges in the conventional database systems that take use-defined functions as a black box. So apart from the database query engine, the database system is an additional system for the use-defined function execution, which is usually different from the query engine. So it requires expensive data conversion to make the whole pipeline work. So on the other hand, it is hard to explore compiler optimizations between the two kinds of different execution environments. Okay, so we first translate the MATLAB functions to HOSIR function with the MATLAB to HOSIR translator. So look into the HOSIR code. So it takes the code from MATLAB. It has the parameter names with the type, and then we translated the query to a HOSIR main function with the SQL to HOSIR translator. So you see from the statement 0, I would say the query has been transformed to the HOSIR code. It first evaluates the T2 is a vector for the discount. It first evaluates the conditions on the word clouds, then perform the Boolean selection to select the qualified rows, like for the price and discount. Then we pass the field, the selected rows to the use-defined functions revenue change scalar. Then we return the result to the T6. Then finally return the total revenue change. Okay, then we will think about, we have the program and how can we optimize the code generated from both MATLAB and SQL queries. And we built the, based on the generated Hot programs, we construct the dependence graph for each function. The main function calls the function revenue change scalar in the node v103, and we can say it's a typical call graph. We can see the main function called the revenue change scalar functions. Then the best way to optimize the two functions together is to perform the method inlining. So we put the two functions into the one, then we think about, then we can perform the in-method optimizations to find the optimizations within the single function. So for example, like automatic loop fusion, we can find the fused nodes inside the one function and all the fusion with patterns to generate efficient code. Okay, so in our evaluation section, we first tested the performance comparison between horsepower and MATLAB. So we had the two benchmarks in the experiment. Both are benchmarks from the financial domains that can be written in MATLAB. The x-axis is for the input data size, and the y-axis is for the execution time. So in terms of execution time, we can see that horsepower is much faster than MATLAB. The reason is that the horsepower provides a compiled system with compiler optimizations to reduce the intermediate results that can outperform MATLAB, which runs on the interpret. So in another evaluation, we created the SQL statements with embedded Black-Scholes use-defined functions, including the query SQL variants with various levels of selectivity for both scalar and the table UDF. So yeah, we choose a popular database system, MongoDB, which supports Python UDF to compare with. The figure shows the speed up of SQL variants between the horsepower and the MongoDB. So overall, horsepower is faster than the MongoDB in all cases except the one case, the SQL statement, the BS too low, because in this case, in this variant, it has a few number of rows, only 0.2% rows after selection, and after the filter with a high selectivity that has little impact on the scalar UDF. So in MongoDB, the table UDF is significantly slower than the scalar UDF because no cross optimizations can be performed on the table UDF, but it doesn't happen in horsepower because of the optimizations we have. Okay. Finally, we say horsepower is a compiler-based approach exploring array-based optimizations to support database queries, MATLAB programs, and database queries with analytic use-defined functions in a holistic framework. So future work will integrate like different program languages and enhance our relational operators. Thanks for watching my presentation about horsepower. If you are interested in our project, please visit our GitHub page. That's pretty much I have today. Thank you.